Dark matter is one of the few objects in space that fascinates both scientists and the general public. One of the manifestations of dark matter is scary as it is surrounded by mystery. Despite the fact that most scientists agree that dark matter makes up most of the universe's matter, we're now set to discover more about dark matter thanks to the new James Webb Space Telescope. Join us as we explore the life-changing revelation of dark matter made by the James Webb Space Telescope. What is dark matter exactly, and how did the idea of it come to be, and why is it the stuff of nightmares in space? Like the mystery surrounding it, dark matter is a mysterious element that may make up approximately 27% of the whole universe. The easiest way to understand dark matter is to consider what it isn't. Therefore, we'll take that approach to fully grasp this idea. As prevalent as atoms are thought to be, according to a cosmological model known as the Lambda cold dark matter model, sometimes just referred to as the standard model, they make up only about 5% of the universe. Additionally, dark matter and dark energy are not related in any way other than the fact that they both share the name dark. According to the standard model, dark energy makes up about 68% of the universe. Dark matter, on the other hand, is invisible because it doesn't emit, reflect, or absorb electromagnetic radiation like X-rays or radio waves. As a result, instruments can't directly detect dark matter because almost all observations of the universe, aside from those for gravitational waves, involve observing electromagnetic radiation with telescopes. Does dark matter interact with visible, well-lit matter despite being invisible? Yes. Dark matter interacts with ordinary matter and has measurable gravitational effects on large cosmic structures like galaxies and galaxy-class clusters. As a result, even though astronomers cannot directly observe dark matter, they can still map its distribution in the universe by observing the gravitational effects that dark matter has on ordinary matter. How did we come up with the concept of dark matter? Actually, Newton's discovery of so-called dark nebula hundreds of years ago gave rise to the notion that there might be objects in the universe that are invisible to us and emit no light. A dark nebula, also known as absorption nebula, is a type of interstellar cloud, particularly molecular clouds, that is so dense that it obscures the visible wavelengths of light from objects behind it, such as background stars and emission or reflection nebulae, and the 18th century theories of phenomena that might devour light and subsequently be known as black holes. Fast forward to the 20th century, when astronomer Fritz Zwicky made the first measurements of what is now known as dark matter, and astronomers began to acknowledge the presence of a so-called dark universe. His 1933 observations of the Coma cluster of galaxies appear to show 500 times greater than what the famous astronomer Edwin Hubble had previously determined. Although Zwicky's results were initially viewed with great skepticism, other astronomers later corroborated them. However, another scientist, Vera Rubin, would play a significant role in persuading us of the existence of dark matter. Rubin offered a significant piece of evidence for the existence of dark matter 30 years later. When compared to a revolving vinyl LP whose core spins faster than its edge, galaxies should logically act similarly. However, since space is not a realm where rationality reigns, galaxies do not behave like a rotating vinyl LP. Instead, they rotate at the same rate as their extremities. The only way to explain this is if the entire galaxy is merely the core of some somewhat larger structure. For example, envision it as being only the label on the LP, causing the galaxy to rotate at a constant rate from center to edge. Following Zwicky's lead, Rubin proposed that dark matter is the missing component in galaxies. Despite the astronomical community's strong opposition to her views, her confirmed findings provided essential evidence for the presence of dark matter. In fact, in recognition of this significant and historic piece of work demonstrating the existence of dark matter, as a result, the revolutionary Huge Synoptic Survey Telescope was recently renamed the Vera C. Rubin Observatory. Despite the efforts of early career astronomers, scientists still don't fully understand what dark matter is made of. However, Webb has the ability to look at the dynamics of galaxies to attempt and approach that in new orthogonal ways. Astronomers can measure the amount of mass in stars and galaxies, for instance, as a sideways way of finding dark matter. Many galaxies could not exist and travel as they do without a significant quantity of invisible mass to aid astronomers in finding their dark matter, which is part of the key evidence for the distance of dark matter. More specifically, the James Webb Telescope will capture incredibly sharp images that will allow researchers to see disturbances brought on by gravitational lensing, guiding them to the location of the hidden mass. When a light beam passes a huge mass, it will be somewhat deflected because the fabric of space-time is slightly warped by the object. By imaging at distant galaxies, the James Webb Telescope may identify these masses and determine what is missing or not observable. This is likely to be dark matter. This form of measurement is very well suited for the upcoming Space Telescope. Due to its extremely crisp pictures, very minute disturbances may be measured. According to information provided about the Space Observation Station, and because it can look so far into space, it has access to a lot more background galaxies to assess disruptions induced by this gravitational lensing phenomenon. Scientists can then compare these data to ideas of dark matter's function in their process, resulting to some knowledge of the amount and nature of dark matter in galaxies. In addition, the JWST will observe numerous statistics of galaxy evolution. The $10 billion James Webb Telescope is intended to allow us to look farther into space than ever before, enabling it to look further into the past. While scientists are anticipating the use of the JWST to research dark matter, the telescope has been safely delivered to its permanent location. By making these observations so far into space, the Space Telescope will investigate the origins of the universe and its galaxies and the role that dark matter may have played in their evolution. It was successful after a nerve-wracking launch that required the most delicate components to be folded up in order to fit the large size of the telescope on the launch vehicle. For example, the delicate but wide heat shield that will shield the infrared instruments from heat interference, as well as the 6.3 meter wide mirror that is broken down into 18 different hexagonal segments, had to be folded. As the JWST traveled to its final destination, which is around 1 million miles from where it will orbit the Sun, both components began to unfold in space. Because there was only one chance to get things right before the launch, NASA had to make sure everything was in order. The telescope is so far away that it is impossible to send a repair mission to it in its permanent location. Even refueling is uncertain, while NASA is open to exploring the concept since the propellant on board the JWST can endure for nearly 2 decades. Initially predicted for 10 years, but an effective deployment has allowed for adequate fuel to extend the mission by 2 decades. The JWST is presently being calibrated and configured by NASA, which is aligning the 18 mirrors to produce coordinated images rather than individual ones. In a few months, the JWST will start to capture breathtaking photos of the cosmos. Professor Matthew Walker of Carnegie Mellon University, who is the principal investigator of a program that will use data gathered in the telescope's first year of operation, is one of the researchers who can't wait to use the JWST. He's going to work on dark matter, but with a twist called dark matter theory. According to the predictions of the dark matter theory, dark matter will be found in small fundamental units termed halos rather than agglomerations the size of galaxies. Now, there is something to note about the JWST, which we will quickly go over here. The telescope is optimized as an infrared telescope, appearing deep into the past and outer reaches of the cosmos. Walker and his team will look for perturbations from the subgalactic dark matter halos on very fragile gravitational systems. The characteristics you desire for a narrow field of view instrument are those that allow you to look at individual objects very closely. When studying dark matter and dark energy, however, you can achieve greater success. Dark energy telescopes attempt to observe a large portion of the sky because this is how we learn about and measure this phenomenon. We add up its effects over a large area or volume in order to learn about and measure it. The Nancy Grace Roman telescope, which is scheduled to be launched in 2027, will in contrast have a broad field of view that will enable it to image large swathes of the sky, which is exactly what is required to measure the effects of enigmatic forces on significant structures or regions of the universe. While Nancy Grace Roman may be able to discover hundreds of distant supernovae, it will be the task of the JWST to make the most accurate measurements of those distant lampposts possible. We will keep you updated on new Nancy Grace Telescope and new discoveries of JWST. Stay tuned for more epic content like this. That pretty much wraps this video up, guys. Thanks for watching. Let us know your opinions on the dark matter and JWST in the comments section below. Remember, be sure to subscribe to this channel with bell notification if you enjoy watching our content. We upload some pretty awesome stuff here, which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.